Now let us return to consider some examples. So here's function f, here's function g. If nothing's written at the back, that means the domain is assumed to be real number, like this. Okay, assumed to be real number. X is real for f, x is real for g. And if no information is given, usually in the IB exam, these compositions are assumed to exist. So you don't have to worry about whether they exist or not at this stage. So no question to ask about existence, then they exist. So the assumption is, so f of g of x, so first you write f. So you write f to big bracket, whenever you see an x, put a big bracket, and then you write 2 big bracket plus 5, and inside the x you put g, which is 3x. So this is the answer. That's it. Next, g of f of x. So now we will write the g first. That is 3 to the power. Power now is written in a bracket because x is written in bracket, and in here we put in the output of f, which is 2x plus 5. And you can simplify this slightly more. It's 3 to the power of 5 times 3 to the power of 2x, for example. Right. Next, f of x. F of x, well, this is relatively easy. So 2 big bracket plus 5, and inside the bracket you're going to write 2x plus 5 because that will be the output of this f of x. So simplifying this will give me 4x plus 10 plus 5. That is 4x plus 15. And here's the answer. Functions given. And again, we're going to assume that all this composition exists. G of f of x, that means write g first. In this case, big bracket, square, because x, every time you see an x, you replace by big bracket. And inside the big bracket, we're going to put in f of x. F of x here is 2 over x. So this simplified to 4 over x squared. That's the answer. Next, g of x. So again, big bracket, square, and inside I'm going to write g of x. This, we're going to write g of x. G of x is itself going to be x squared. So the answer in this case is x to the power of 4. All right, please recall your index law. The last one is g of 2. Well, that just basically, we have redone g of x here. So that basically just replace 2 into x. So it's 2 to the power of 4. That's 16. Let us consider another example. Here we have f of x equals to natural log of x. X must be larger than 0. And here's another function. We have to identify the range of f and g. Now, given this particular domain f, so you can sketch it out. Logarithmic curve looks something like this, right? X, here's y. This is f, l, and x. So you can see that the range of f is actually all real. It's all real numbers. And we can look at g of x. G of x is x plus 1. So something like this, g. Here, let's say it's 1. This is x plus 1. So you can see that the range here is also all real. All right, then we have to consider this question. Does f of g of x exist? So for f of g exists, then we must want to find that the range of g must be a subset of the domain of f. The range of G must be a subset of domain of f. This is what we need to check. We need to check this. And if we have this condition, then we can say that our function exists. So since our range of G is real and domain of f is only x is greater than 0, then obviously here range of G, which is real, is not a subset of x is greater than 0. Right? So in this case, f of g of x does not exist. For example, I can get an answer in g of x which is negative value here. So the output is negative value, but the negative value cannot be put into natural log of x. You will not get a real number. So the function does not the composition does not exist. Next, does g of f exist? Well, so again we want to find whether that is the range of f is actually a subset of the domain of G. What we know is that the range of f is actually all real number. And the domain of G is also all real number. So in this case, they are the same size. But the same size means the subset range of the f is a subset of G's domain of G. So this is okay. So in this case, G of f exists. And we can calculate G of f. So G is, we write G first, G of f. So we set for G, so big bracket for the x plus 1, and inside the bracket I put f, natural log of x. So this will be natural log of x plus 1. Now next, find the domain and range of the composite function that exists. So we're looking at this. That's my composite function. And I want to find the domain and range. Well, the domain here, you can see that, well, it's really controlled by the input to ln x. All right, what is the input to ln x? Well, in this case, it's just x greater than 0. So the domain of g of f of x, right, is the domain of f. So in this case, it's the all x greater than 0. And the range of g of f of x obviously also controlled by the domain. So there's all natural log of x plus 1